Google just built an AI that predicts physics more accurately than the laws we've used for centuries, and it's not using equations. This isn't hype. This is a fundamental shift in how machines understand the world. So what exactly did Google do? They created something called a world model. Think of it as a digital twin of reality that can watch a video of the world and predict what happens next. Not by calculating force and acceleration like Newton would, but by learning patterns directly from millions of hours of video footage. Here's where it gets wild. Traditional physics works like this. You know the rules, you plug in numbers, you get an answer. A ball falls. Gravity is 9.8 meters per second squared. You predict where it lands. Clean, mathematical, reliable. But the real world is messier than our equations. There's air resistance, spin, friction, material properties we barely measure. Most physics simulations have to ignore or approximate these things. So they're always a little bit wrong. Not catastrophically wrong, but wrong enough that engineers build in safety margins and error buffers. Google's world model doesn't care about the equations. It watches video. Thousands of videos of things moving, falling, colliding, rolling. It learns the patterns. And then it can watch a new video, one it's never seen before, and predict the next frame. Then the frame after that. Then 30 frames into the future. And here's the shocking part. In tests, it's more accurate than traditional physics simulators. Not by a tiny margin. By a lot. Why? Because the AI isn't trying to reduce reality to a formula. It's learned the actual texture of how the world behaves, including all the messy details we usually ignore. Air resistance, friction, the exact way materials deform. It's all baked into the patterns. Now, you might be thinking, okay, that's cool for videos, but what does it actually change? And that's a fair question. The answer is everything in robotics, engineering, and how we simulate reality. Right now, when a roboticist wants to train a robot to pick up a cup without breaking it, they simulate it thousands of times in software first. The robot learns in simulation, then we try it in the real world. But if the simulation is slightly wrong about friction or material properties, the robot fails. So we have to retrain it in the real world anyway, which is expensive and time-consuming. With a world model that actually understands physics better than our equations do, that gap shrinks. The robot trains in simulation and transfers to reality much more smoothly. You need fewer real-world trials. You save time. You save money. You can build more complex robots faster. There's another implication that's even bigger. Right now, most AI models, language models, image models, are trained on static data. Photographs, text. They don't really understand cause and effect, or how things change over time. They pattern match really well, but they don't have a model of how the world actually works. A world model changes that. It's the beginning of AI that doesn't just recognize patterns, but understands dynamics. Understands that if you push something, it moves. If you heat something, it expands. If you break something, it doesn't reassemble itself. This matters because it makes AI systems more predictable, more aligned with how reality actually works. Right now, when a language model hallucinates or makes a weird mistake, part of it is because it has no internal model of physics or causality. It's just pattern matching at scale. A system with a real-world model would be constrained by that model. It would be harder to trick it into saying something physically impossible. Now, Google isn't the only one doing this. Meta and other labs are working on similar things. But Google's version is notable because it works at scale and it actually beats traditional physics. That's the bar. Not just as good as. Better. There are limitations, of course. The model works best for short-term predictions. 30 frames is seconds of video, not hours. For very long-term predictions, errors compound. And it's trained on videos of specific types of scenes. You can't just point it at anything and expect it to work. But that's a detail. The principle is proven. AI can learn the physics of reality better than we can write it down. So what does this mean for you? In the near term, probably nothing you notice directly. But in 5 years, when robots are doing more complex tasks, when simulations are more accurate, when AI systems understand cause and effect better, that's this. This is the technology that makes that possible. The wild part is that this isn't the end point. This is the beginning. Researchers are already asking, what if we combine world models with language models? What if an AI could watch a video and understand not just the physics but the context, the intent, the story? You'd have a system that understands reality in a much deeper way. That's the bet. Not that AI will replace physicists, it won't, but that AI can learn to model reality in ways that are more accurate, more flexible, and less dependent on human-written equations than the methods we've used for 300 years. If you want to actually keep up with AI breakthroughs like this before they're in the news cycle, subscribe. I break down one of these every few days. No hype, just what actually matters. Thanks for watching.